Welcome to this video on the reactance of inductors and capacitors. I hope you find this useful. So reactance is the opposition of current flow due to inductors and capacitors in an alternating circuit, and impedance is the sum of resistance and reactance of a circuit, represented in rectangular form. The imaginary part of the impedance of a circuit is the reactance. We will investigate how inductors and capacitors work in different ways, and we will look at two simple examples. Impedance is represented in polar form and is the summation of the real resistance and the reactance. Reactance is the imaginary portion of impedance as seen in figure 1. A capacitor is a device that stores charge in the form of an electric field and strongly resists voltage changes, and thus voltage lags current. The reactance of a capacitor, Xc, is equal to the inverse of the angular velocity times the capacitance, or the inverse of 2 pi times the frequency times the capacitance. An inductor is a device that stores charge in the form of a magnetic field, strongly resisting the flow of current, and thus voltage leads current. The opposition to charge is due to the continual interchange between the energy source to the inductor. The reactance of an inductor, XL, is equal to the angular velocity times the capacitance, or 2 pi times the frequency times the inductance. With both formulae, we need to be conscious about what units we are in, which will be shown in an example. As mentioned earlier, the current and voltage display varying phase characteristics between inductors and capacitors. Civil is a useful tool used to remember the differences. In a capacitor, current leads the voltage, and voltage leads the current in an inductor. Here is a quick example of the reactance of a capacitor and an inductor. For the capacitor, the reactance is 1 over 2 pi by 50 Hz by 47 by 10 to the negative 6 farads. So you can see we convert microfarads to farads. An important step to get the correct answer, 67.7 ohms. For the inductor, the reactance is 2 pi by 50 Hz by 10 to the negative 3 Henry. Again, we convert from millihenries to henries to get the correct answer in ohms of 3.14. Thanks for watching, guys. Hope you enjoyed the video.